Hi, I'm Tommy, and I'm back for a new series. This is Tommy Teaches, and the first class I'm going to be teaching is Algebra. I recently asked some friends on Facebook what math course adults needed a refresher on, and I gave them the choice of algebra, geometry, and trigonometry, and overwhelmingly the response was algebra if they were going to pick one of those three. So that's what we're going to start with. Now, I've picked two textbooks, and they're both free for you, so you can go get them. And the first one is from 1904. It's called First Steps in Algebra. It's free from Project Gutenberg. Now it's available as a PDF or a LaTeX file. If you know anything about LaTeX, you could get that, but if you know about LaTeX, what are you doing learning just algebra right now? Now, LaTeX is a way of writing math formulas so that computers can display them properly on the screen, the way we want to read them. And I'll probably cover that more later on. Probably not this course, but and the second textbook is CK through 12's Algebra 2nd Edition, Volume 1 from Amazon in the Kindle format. And I'll have links to both of those down in the description. They each cover the subject in a different way, so depending on your learning style, you may find one more helpful than the other. And I'll probably start with the classic textbook and go through the format and method that it describes, teaching a bunch of definitions up front and then doing exercises. And I'll probably circle back around to the modern textbook to cover graphing and the graphing calculator. Probably not this episode, but in the next episode there'll start being homework assignments done in the doobly-doo, and then after that there'll be the answer key for the previous episode in the doobly-doo. Now, I'll try to mention how much time to expect to work on an assignment if you're actually going to do them. And if you feel like you're getting stuck on a concept, just let me know and I'll be happy to do a more focused topic video that supplements the main course. Now, today I just want to cover the first 23 definitions and concepts from the first steps in algebra with some lower thirds just to illustrate the proper terminology and formats in arithmetic before we get really deep into what algebra actually is. And then in the next episode I'll cover the next 15 definitions and we'll stop and do some exercises, and there'll be a homework assignment if you want to do that. So algebra, like arithmetic, treats of numbers. And another term we use is units. In counting separate objects or in measuring magnitudes, the standards by which we count or measure are called units. So if we're counting the colors in the pride flag, the color is the unit. If we're buying condoms by the dozen, the unit is a dozen condoms. If you're buying soft drinks by the case, the unit is a case of soft drinks. And if you're measuring short distances, you might measure by the inch or the centimeter, depending on if you want to make the number look bigger. And for bigger distances, the mile or the kilometer, for the same reason. Numbers. Repetitions of the unit are expressed by numbers. Quantities. A number of specified units of any kind is called a quantity, as in 4 cock rings or 5 vibrators. We use numbers as symbols in arithmetic, and you're familiar with these numbers. Arithmetic employs the arbitrary symbols for 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And we call these figures, and they represent numbers. But in algebra, we use additional symbols from the alphabet. Letters are used as general symbols of numbers, to which we can assign any particular value. Now, we typically use letters from the front end of the alphabet, like A, B, and C, to represent numbers we do know or should know, and numbers from the back end of the alphabet, like X, Y, and Z, to represent the numbers that we want to know, and that we're using algebra to find. So let's start with the principal signs of operations. Now, the sign of fundamental operations are the same in algebra as in arithmetic, so you should know addition, subtraction, multiplication, and division. So this is the symbol for addition, and we call that plus. And when you read that in an expression, it's 4 plus 2 with the plus symbol in the middle. Now, subtraction, we use this symbol for subtraction, and it's read as minus, so 4 minus 2. And multiplication, there's several symbols for multiplication. We typically use an X or a dot. And so 4 times 3, and you read that as times. Or A times B, if you're dealing with just letters. Now, the dot is sometimes used, and so you might see 2.3.4.5, and that means the same as 2 times 3 times 4 times 5. Now, the sign of division, this is a common sign of division. It looks like a minus sign with two dots, one above and one below. You might also see it written with numbers with a bar separating them, or you might see it written as a slash mark with modern computers. And this is read as divided by, so 4 divided by 2 or 4 over 2 is the same as 4 divided by 2. We use other signs in algebra that you may or may not be as familiar with. The first one, I'm sure you know, is the equal sign, the sign of equality. And that's the same symbol that the Human Rights Campaign uses, with the blue and yellow equal sign in the square. Now when you're reading this in an expression, you just say equal to. And it usually means that both sides of the equal sign represent the same thing. So 8 plus 4 equals 12 means that 8 plus 4 is the same as 12. Now if you see x plus y equals 20, that means that x added to y together make 20. Now some other signs you may not be as familiar with are the signs of inequality. And you see this symbol and this symbol meaning less than or greater than. And the side that opens out is always the greater side. So you might say that 9 plus 6 is greater than 12, or that 9 plus 6 is less than 16. And if you use the internet much at all, you might have seen this particular inequality, I less than 3u. Oh, I less than 3u. Now here's a symbol you may not be as familiar with. This is 3 dots in the form of a triangle, and that is called the sign of deduction. And when you see that written out, you would read it as hence or therefore. Now the ellipsis is commonly used in grammar and things, but in algebra you would read it as and so on, the sign of continuation. Now you might not realize these are all signs of aggregation, and the most common one is the parentheses, but also the bracket and the brace. But you might also see things written like this with the bar, where you get to be the bartender, and the vinculum. Now all of these expressions mean the same thing, a plus b, separated from something else. They're all just different ways of writing the same thing. Typically we'll use parentheses, but if you're stacking up parentheses, you might start using brackets and braces to distinguish where one set of parentheses starts and ends. Factors, coefficients, and powers. When a number consists of the product of 2 or more numbers, each of these numbers is called a factor of the product. The sign times is generally omitted between a figure and a letter, or between letters. Thus, instead of 63 times A times B, we just write 63AB. And instead of A times B times C, we write ABC. And don't get that confused with A plus B plus C. A plus B plus C is a sum, and ABC is a product of A times B times C. Factors. Factors expressed by letters are called literal factors, and factors expressed by figures are called numerical factors. Now if one factor of a product is equal to 0, then it's called a 0 factor, and the product is equal to 0 also. You probably knew that from arithmetic. If you multiply by 0, you're going to get 0. Coefficients. A known factor of a product which is prefixed to another factor to show the number of times that the factor is taken is called a coefficient. Thus in 7c, 7 is the coefficient. In 7ax, 7 is the coefficient of ax, or if a is known, then 7a is the coefficient of x. By a coefficient we generally mean just the numeric coefficient with its sign. If no numerical coefficient is written, 1 is understood. Thus ax is the same as 1ax. Powers and roots. A product consisting of 2 or more equal factors is called a power of that factor, and one of the equal factors is called a root. So in 9 equals 3 times 3, so 9 is a power of 3, and 3 is a root of 9. Indices or exponents. Now an index or exponent is a number written smaller and slightly above another number, and we call that a superscript now. And if the index is a whole number, it shows the number of times a given number is taken as a factor. So a superscript 1, we would usually just say a, and let the 1 be implied. It denotes that a is taken once as a factor of a. A squared, or a to the 2, denotes that a is taken twice as a factor. A to the 3rd denotes that a is taken 3 times as a factor. And a to the 4th, or a superscript 4, denotes that a is taken 4 times as a factor, and so on. Now these are read the first power of a, the second power of a, the third power of a, the fourth power of a, and so on. And instead of writing a times a times a, we just simply write a to the third power, or a superscript 3. Now there's also coefficients, and the coefficients and the exponents, you want to pay attention. They're related in a way, but don't get them confused. So 4a is equal to a plus a plus a plus a plus a. And a to the fourth power is a times a times a times a. So if a equals 3, 4a equals 3 plus 3 plus 3 plus 3, which is 12. But a to the fourth power, 3 times 3 times 3 times 3 is equal to 81. You see, they're really different. A squared denotes the number of units in the surface area of a square, and a cubed denotes the cubed units of volume in a cube. So then we say a squared and a cubed, or the square root of a and the cube root of a. Well, that's our definitions for today. I hope this refreshed you a little bit and wasn't a whole lot of new territory. If you need something else, if you need one of these particular terms explained in more detail, I'll be happy to do that. But I hope the lower thirds popped up and showed you what to expect and refamiliarized you with some of these terms. Now, if you know somebody that needs a little lift, a little refresher course in algebra, I hope you'll hit that share button down below and send it to them. And if it's something you need for yourself, I hope you'll hit the subscribe button and tune in again in a few days when I'm back with the next group of definitions and a homework assignment. Now, the homework assignment will be in the next episode, and then after that there'll be a homework key in the following episode. I'm Tommy, and this has been Tommy Teaches, and I hope you learned something, or at least remembered something that you might have learned before. Thanks for watching.